Hello, everybody. It's me, your favorite person. Hey, Miss G and Mr. Mozo said we're talking about water. I love water. Hey, Benny, what are you guys doing over there? Hey, get out of here. Oh, I'm sorry, Mr. Mozo. Sorry about that. My friend, Benny, he really likes water. He's like, certainly do. We don't need him right now. You have other things to do. Take care, buddy. Yes, everybody, we're talking about water and streams. So, water is the most important agent of erosion. We've talked about erosion before. Erosion is when our friend water, right here, water, we all know what water is. Oops, I got our laptop all wet. Excuse me there. Water is very important to erosion.
Yes, wind is important too, but not when we're talking about water.
And that's part of our stream. So you guys saw that in class, how our stream was eroding away the sides during our experiment using our water table. It grinds the channel. So think of this as a channel on the side of a stream. That water is going to run through here and break off this rock. And as it breaks it off, it's going to fall off into that stream. And in that stream, those particles, they're going to lift up in that water. So if I take some of this rock right here, got a little piece here, it's going to go into that water, and this kind of goes out to the bottom. Looser particles and lighter ones would float in that stream. You guys saw that, like I said, in our demo in the classroom. It's going to take the particles that it erodes off this rock. Think of this as the side of the stream. It's going to take these and it's going to take it all the way down the stream, and it's going to drop them. It's going to drop them at the bottom of a gulf. It's going to fill up at the mouth of the river. Again, that is how water affects erosion in streams. I hope you like Benny. Thanks, Benny, for helping us out. No problem, Mr. Mozel. And we'll be back in a second with some more. Thank you.
All right, to summarize all of that, water grinds channels, lifts loose particles, transports the particles, and then deposits them.
All right, everybody, I'm back. And this next topic, not that exciting, but I think it will help you out understanding how streams transport these sediments down to the end, to the mouth of the stream. It depends on the size. So first we have our first type of sediment transport in the solution is called a dissolved load. And if you think of the word dissolved, that means it's going to kind of dissolve into the solution, into the stream, and just float down with that water. These are your fine, very small grains, so stuff that would, if you put some sugar in water, think of that. The sugar dissolves in water, and you can't see it anymore. So think of the same thing as this dissolved load. The amount of the dissolved load, how much dissolves in the stream, depends on the climate. So depending on if it's hot or warm or cold, depends on how much dissolves in that stream. Our next one's called in suspension. Think about that word, suspension. Good. You thought about it for a second. Suspended load means that it's suspended. It's carried, and you saw me look at the notes. Yes, I'm looking at some notes. It's carried down the stream. It doesn't dissolve. It's just carried in that water. Think of your sand, your silt. Wait for it. And clay. All right. So you got your three: sand, silt, and clay. Those would not be dissolved, but suspended in our stream water. Uh, During floods, think about during a flood, you have a lot of stuff coming into the water. A lot more water is coming into those streams. A lot of stuff's inside that water. So the more water that happens more water that comes into the stream during a flood, the more suspended load you have. And last but not least, we call them the scoot along the bottom load. Just think about that. What size particles will scoot along the bottom in a stream?
I think you mean bed load.
Again, think about it. Give it 5 seconds. 1, 2, 3, 4, 5. I think you got it. Yep. It would be the heavier items floating in that stream. So they kind of move along the bottom. So if you've ever been rafting before, this heavier material sits at the bottom of these streams. And if it's not too heavy, it'll scoot along the bottom of these streams.
Sorry, Mosul, this is called bedload. Those pieces of broken off bedrock that sit at the bottom of the stream get scooted along the bottom. Yes, but they're called bedload.
They move only when the force is great enough. So think of a flood. When there's flood, there's a greater amount of water moving through these streams, and that will push a lot of this heavier load down the stream. The grinding that results from these heavier stones, material, this load, similar to this, but a lot bigger than a rock like this. I can't be holding it right now. I'm not that strong enough. Will grind away at the channels. So you have your stream, and it'll keep grinding and grinding, and as it grinds, it makes that channel for the stream bigger and bigger. Oh, you caught me. I was playing with the water. Silly me. This video's taking a long time. I shouldn't have been doing that. But I have two important terms that you should know. One's called competence, and the other one's called capacity. So you want to make sure in your notes that you get these down. Competence, all that means is the largest particles a stream can carry. I should have studied this a little bit better. I'm looking at my notes again. So again, the competence is the largest particles a stream can carry. Got that? And the second one I was telling you about is capacity. Think of the word capacity. You think of a capacity you see in your classrooms, you see a sign on a door saying 150 limit capacity to this room. That's the amount that the room can hold. So think of the same thing for a stream. Capacity, all that means is the maximum load a stream can carry. So it's as much as that stream can carry, both dissolved, stuff that's suspended, and the stuff at the bottom of the stream, the bed load. So think of capacity as the amount a stream can hold. And again, competence was the largest particles a stream can carry. All right, kids, really quick. I got rid of Mr. Mosul for a second to talk to you guys about something very important. I'm going to talk to you guys about deposition. Do you guys know what deposition is? Sure you do. All deposition is depositing things. Right? We talked about deposition before. In deposition, when we're talking about streams, the dropped particles are called alluvium. Do you guys know how to spell alluvium? Nah, probably not. I'll help you out. Alluvium is spelled A-L-L-U-V-I-U-M. Did you get that? I hope you did. If you didn't, just rewind a little bit and you can watch me again. So when a stream is very slow, there's a low discharge. All right, slow, everything's going slow. There's a low discharge, not a lot of stuff coming down. So this equals a low capacity. Again, remember that word? I think Mr. Mosul told you before. Low capacity. Capacity was the maximum load a stream can carry. So when a stream is moving slow, there's a low capacity and particles drop. All right, they start dropping to the bottom of that stream. I bet you can't guess what drops first, the lightest or the heaviest particles. Nah, you guys are all smart. It's the heaviest ones. The heaviest ones will drop to the bottom of that stream first, followed by the lighter ones. As those light ones move down the stream, though, they'll stay suspended inside that stream, and once they reach the end of the stream, it opens up when it enters a lake or ocean, and we call this a delta.
Delta.
Basically, a delta is accumulation of all that sediment that made it down the stream. Did you get that? I hope you did, because Mr. Mosul is coming in here. So, I gotta go. See you later. Hey, get away here, Mosul. We're going to talk about stream valleys. I'm not sure how many of you have ever gone whitewater rafting before, but it is fun. It is a lot of fun. I once lost my raft and I was stranded on a rock. So a narrow stream, so something that's really narrow in a stream, you can get rapids and waterfalls. And when you get rapids and waterfalls, you're going to be moving around like this. You're going to be bouncing around. So that's what's going to happen. And as you go through those waterfalls, eventually you're going to hit a narrow stretch. It's going to be nice and easy. All right, your raft's not going to go anywhere. And those wide streams are, after cutting deep, they get very wide. So your narrow streams are going to have rapids and waterfalls. And your wide streams are going to be cut deep and they're going to be cut wide. So they're going to be very wide from side to side. Also, these results in what's called meanders and oxbow lakes, and I'm sure Miss G will put some good pictures on this video once I'm done talking to show you what those look like. They're also in your textbook. A meander is kind of where it goes back and forth, back and forth. And oxbow lake is kind of when those go back and forth. Sometimes they erode away, and when they erode away, you get a lake that'll form to the side of that stream or river. You also get something called floodplains, and these are areas that flood a lot when a river overflows. If you know anybody that lives by the Mississippi River, you might want to talk to them, because when it really rains a lot by the Mississippi River and it overflows, a lot of homes do get flooded. And actually there's a river not too far away from here, the Des Plaines River, and there's one that goes right through Lansing. I forgot what the name of it was. If you come up with that answer, you could always tell me, because I don't live
That's the Little Calumet River.
here. But when that also overflows, you're on a flood. Some homes are on the floodplain here in the Lansing, and you get water in the basements. So hopefully you liked everything about streams. I know it was super exciting. You loved it, and I'll be back in a second to talk about floods.
No, you won't be back. We're going to end this here and now because it's been almost 12 minutes and you're bored. So that's it for tonight's notes, and make sure you have them done so you can get your points when you come into class tomorrow. And tomorrow night's homework will be the flood notes.